Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good evening to all of you. Welcome back to the class of BAA2213, the reinforced concrete design. Today in this video, we will discuss about the exercise number 14, which is the design of simply supported one-way slab. Okay, I hope you can see my screen now. Okay, this is based on your module. Okay, example 2.1 of your module. Okay, but I want to change the dimension. Okay, so I hope you are ready with your answer, standard answer script, answer sheet. Okay, and then, okay, please okay, write down the value or the data I give to you. It's number 14. So for this module, I want to change the value. Okay, I want the thickness. Okay, the data is here. You can read later. Okay, now I want to change the thickness. Sorry. The L, I want it to be 4.0 meter. Okay, the permanent load will become 1.5 kilonewton per meter square. Which is this one is excluding the surf weight. The variable load, I want to try the 3.5 kilonewton per meter square. Okay, this one is in this exercise, I want to give the value of C nominal. Okay, I skip the step of determine the C nominal because in the exam or in the midterm, usually the C nominal is given. So we can use the given value of C nominal. But during the real practice, okay, once you are working with consultant letter, inshallah, you have to determine the value of C nominal. But it's okay. We will discuss about the C nominal or the concrete cover later. Okay, by the end of the semester. Okay. And then the C nominal is given as 30 millimeter. Diameter of bar is 12. Okay, maintain. Okay, concrete density is 25 kilonewton per meter cube. Okay, the unit is meter cube. FYK 500, FCK, let us try FCK of 30. Okay, Newton per millimeter square. Okay, so this is our data for the design, and this is our slab. Okay, I hope you can imagine the shape of our slab. Simply supported. Okay, simply supported slab. Okay, let's say this is a simply supported one-way slab like this one. This is this is the cross section actually. I want to draw the plan view first. Okay, the plan view is like this one. This is your bigger. Okay, larger is better. This is your slab. Okay, from top view. Okay, this is the hidden line, means we have beam under the slab. Okay, and let's say this is beam A, let's say beam 1, and this is the beam 2. Okay, and then the L is here. Here is the L is equal to 4.0 meter. And then since this is simply supported, so the forces or the loading from the slab will directly being transferred to the nearest beam. Okay, in the case is here. Okay, half of the load from the slab will be transferred to beam number 1, and another half will be transferred to beam number 2. Okay, like this one. Okay, so if we cut the cross section, okay, let's say this is the cross section. Okay, cross section 1, 1. Okay, we do the cross section here like this. Okay, this is the cross section. Shall be like this one. Okay, sorry, I have to enlarge the here. So I can, so all of you can see the detailing later, how to do the detailing. So the solution here is, okay, I don't want to waste the time by writing the data. So the solution, let's make here. Solution, the first solution is we determine the action and analysis. Okay, first is the safe weight of the slab. Okay, equal to HF multiplied by the density of concrete. So it's equal to, okay, equal to what? Equal to 0.15, 175. Okay, I use, sorry, I give the data here, I give the value as HF is equal to 175. Okay, let's try the HF is equal to 175. Okay, HF is equal to 175 mm. So the safe weight of the slab, okay, okay, what is the value? The safe weight of the slab?
4.375.
4.375. So let's make it as 4.5 kilonewton per meter square. And then the permanent, okay, permanent action, okay, without safe weight is equal, okay, this is GK as given before, equal to apa, 1.5 kilonewton per meter square. So we can determine the total permanent action. GK is equal to, okay, can you total up this one? 4.4 plus 1.5. What is the total? Kilonewton per meter square.
5.9.
5.9. Okay, thank you.
5.9.
Okay, good. 5.9. And then the variable action, the QK, okay, the base is equal to, this one is they use capital small letter GK and QK because the unit is in, this is area load. Okay, this is the area load concentrated on area. So the unit is kilonewton per meter square. If the unit is kilonewton per meter, let's say on the beam, so the symbol is GK, okay, capital letter of G and capital letter of Q. Okay, that's the difference. Okay, you must know. Okay, so this one GK is 3.5 kilonewton per meter square. Okay, and then so we can determine the design action. Okay, and D is equal to 1.35 GK plus 1.5 QK is equal to 1.35 times 5.9 plus 1.5 times 3.5. Okay, any answer for this? Okay, any answer?
13.215.
Okay, make it 13.22. kilonewton per meter square. Okay. And then since this is still design, okay, for the whole. Okay, let's say this one from top. This is designed for the whole. Okay, and D is equal to 13.22 kilonewton per meter square. Means for every 1 meter square, let's say this is 4. Okay, for every 1 meter square here, let's say this is 1 meter. This is also 1 meter. For every 1 meter square, the loading is equal to ND here, which is 13.22 kilonewton per meter square. So we want to design the beam. To design the beam, we have to design for every 1 meter. Let's say we don't care how many meters it run. So we design for every 1 meter. Let's say here 1 meter. Okay, because we know the loading will go to the B1 and B2. So this is our slab to be designed. I mean for the calculation, okay, to simplify the calculation. Okay, so this is 1 meter for 1 meter run. Okay, so we can convert as just like the simply supported beam. Okay, simply supported beam with the B is equal to 1000 millimeter or 1 meter. Okay, the B for the slab design, the B always 1 meter and no flange. Okay, please don't confuse. So we just design as a rectangular. Okay, follow the procedure of rectangular beam with the B is equal to here. B is equal to 1000 millimeter. And the HF, the thickness is depend, okay, on the situation given. Sometimes it's 100, 125, 150, 200, and so on. Okay. So just like the rectangular beam, you just follow the step. You calculate the K, the Z, the D, and so on. Okay. So for every 1 meter width of the slab, and D is equal to 13.22 times 1 meter. Okay. So the answer now is equal to still similar 13.22 kilonewton. Now the unit is per meter because it's 1 meter, so you cancel out the another unit meter here. Okay. I hope you are clear with this one. So you can do the part of analysis. Okay, by calculate the simply supported. Okay, this is the B1 and this is the support. Okay, from B2, and then the loading here. Okay, W is equal to and D is equal to 13.22 kilonewton per meter. So what is the MED now? What formula you want to use?
WL square over 8.
Oh, ini sensitive formula ni, you kena ingat. Okay, WL square over 8 equal to 13.22 times 4 meter square. Okay, divide by 8, so equal to
26.44.
26.44 kilonewton meter. Okay, how about the VED? Equal to?
WL over 2.
Okay, good. WL over 2. So equal to 13.22 times 4 divided by 2. So the answer is
26.44.
okay, 26.44. Okay, similar to the bending moment. This is coincidence. Okay. Okay, so usually 1 mark. Okay, 1 mark for the design actions, 1 mark for the safe weight. Okay, you calculate one safe weight is 1 mark, design action 1 mark, moment 1 mark, VED also 1 mark. So you also already score 4 marks here. You can, if you can do up to this part. Okay, and then part number B. Part number B of the solution is design of main reinforcement. Okay, and then so you just design as the rectangular beam. But rectangular beam in condition that the width is larger than the depth. Okay, for the beam, okay, this is the width B of always equal to 1000 mm, and then the B is always larger than the depth of the. If the beam, this is the situation. Okay, this is the B, and then this is the UH of the beam. Okay, that's the difference. Okay, so what we are going to do is first you calculate the value of your D is equal to okay, D is equal to HF minus your C nominal and your minus your diameter. Directly diameter, because you don't have link usually. Okay, and so HF is 175 minus 30 minus your, sorry, diameter must be divided by 2. Okay, 12 over 2. So what is the answer? Okay, what is the answer?
139.
Sorry, 139. Okay, good. 139 mm. So another 1 mark here if you score. So the value of K is equal to M over FCK dot B dot D square is equal to 26. Sorry, use red color as the input. 26.44 times 10 to the power of 6 divided by. Usually, in the exam, I prefer you to use just one row of calculations. Okay, please don't make confused by. Sometimes you students, they want to save the paper. They make divide the paper by two columns, but it make me confused. Okay, so you better just use one single column of the paper, and the B is always equal to 1000. And the D is 139 square. So what is the value of K?
0.046.
0.046. Okay, lesser than 0.167. So this is singly reinforced. You write down the conclusion. So this one, another 1 mark. This one, another 1 mark. Okay, usually. Okay, and then the value of D is equal to D ke? Z, sorry. Z equal to D times 0.5 plus square root of 0.25 minus K divided by 1.134. So equal to D 0.5 plus square root of 0.25 minus 0.046 divided by 1.134. Any answer?
0.96.
0.96D larger than 0.95D. So you use Z equal to 0.95D. Okay, you limit to 0.95D only. And then you can directly proceed to as required. Is equal to M over 0.87 FYK times Z is equal to 22 to 26.44 times 10 to the power of 6 divided by 0.87 times the 500 times 0.95 times 139. So what is the answer now?
mm square.
Okay, 460 mm square per meter. Okay, that's the unit. For every 1 meter means, okay, here Okay, I believe I can delete this one. For every 1 meter here, you need as required is 460 millimeter square for every 1 meter. Okay, if you have 5 meter, and then you will arrange the reinforcement for 5 meters. Okay, so I believe I can delete this one, so you can refer to the video later. Okay, so this is because I want to draw the detailing here. Okay, so for every 1 meter, okay, it's okay. Oh, sorry, padam lah pula. Okay. So, you refer to the table. You refer to the table of steel reinforcement. Okay, which table lah? You refer to this table. Okay, this is the table at the top. You use for beam design, but for the slab design, you have to refer to this table. Okay, so let me print screen. And then I will paste here. Okay, so you can Google from the internet. Okay, I Google from the internet this table. Okay, for this table, oh dia tak cantik lah pula. Tak apalah. Okay, for this table, so for this case, which you want to use? Okay. You calculate the D based on diameter 12. So this one, okay, I show you. Be careful about this one. Okay, you use diameter as 12, so you just only refer to 12 mm diameter. So you can refer, you need 450, so you 460, so you refer to the largest one. Okay, which one is larger than 460?
H12 225.
Okay, 225. Okay, this one 225. Okay, because it will give you as provided as 503. Okay, you also can use H 200, but for economical you use this one. Okay, this one also right, this one also right, this one also right, this one also okay. But for economical, you use just a slight larger than the AS required. Okay, so you provide. Okay, so you provide H12 at 225 mm center to center. Okay, which will give you AS provided equal to 503 millimeter square per meter run. Okay, another 1 mark here. Okay, this is 1 mark, 1 mark for Z, 1 mark for S required, 1 mark for AS provided. Very simple. And then you have to check okay, as usual, you check the AS minimum and AS maximum. So the AS minimum is equal to 0.26 FCTM times BD divided by FYK. Oh, it must be greater than 0.0013 BD. So equal to 0.26. What is the value of FCTM?
2.9.
Okay, 2.9 dah hafal dah biasa buat. Dah biasa buat je hafal lah. And then B is equal to always 1000 and then D is 139. So divide by 500. So greater than equal to 0.0013 1000 times 139. So what is the answer now here?
$210.
Okay, 210 mm square greater than
181.
Okay, 1 millimeter square. Okay, thank you. So you use AS minimum equal to 210 mm square greater than sorry, which is this one is okay AS provided tadi. Okay, this one is AS provided 503 is greater than AS minimum, so it's okay. And then so always AS maximum you always equal to 0.04 AC equal to 0.04 BH. Always H, okay, not the D. So 0.04 times 1000 times 175. Okay, it's equal to
7,000.
okay, good. 7,000 millimeter square. Okay, which is greater than AS provided. So it's okay. Okay, and then you have to provide the secondary bar for the secondary bar means a bar which in different direction. Okay, provide secondary bar for the steel. You can use also H12. Okay, to simplify, and we try secondary bar at 400 mm square, 400 mm center to center. It will give you as provided equal to 251 mm square per meter. Okay, don't panic. I will teach you how to got this one if it's not in the table, because the table usually provide up to 300, right? The table provide up to 300 only. Okay, this is for economical. If you want to provide secondary bar, let's say you want to provide 300 mm center to center, it's okay. And then you got as provided is equal to 377. Okay, 377. Okay, 377 millimeter square per meter. This is okay, but this is uneconomical. Okay, because we have more number of steel bar because the spacing is closer. Okay, so as long as it this one is larger than AS minimum, because our AS minimum is 210, we provide 251. It's okay. Okay, so okay, this is important. Okay, I want to show you how to I want to show you how to determine the AS provided. Okay, this is important. Okay, let's say for every 1 meter, okay, let's say you are not given the table. So for every 1 meter here, okay, let's say for you can know. Okay, you can go to the table Okay, let's say okay lah, this one. Okay, the table. Sorry. You refer to this table. Okay, for 1 bar of AS to 12 mm diameter. Okay, for 1 bar, what is the value of AS for 1 bar? This one, okay, 113. Okay, 113 mm square. Okay, so this one for 1 H12 AS is equal to 113 mm square. So for every 1 meter, let's say, so this is for 1 meter. How many steel bar you can get? Okay, that's the question. So if your spacing is 2 to 5, let's say here, your spacing is let's say 2 to 5 for every 1 meter. Divide by 2 to 5, 4 point double something, blah 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 kan. Sorry, okay. So okay, for every 1 meter. This is quite hard for me to explain. So let's say I use H10 H12 at 200. Okay, so 1 meter is equal to 1000. Okay, 1000 divide by 200. Okay, 1000 divide by 200. So I will got 5 space. Okay, so the space, so this is a half of the bar here. You will okay, at the bottom, sorry, a bit to the bottom. So this is the half of the bar here, and then this is another half of the bar. For every 1 meter, okay, for every 1 meter, I will have how many bar? Okay, this is 200 for every, let's say this one, 200, 200, 200, 200. Okay, okay, the everyone take is distance about 200 millimeter. I hope you can see on your screen. So the diameter is here. Okay, this is another bar, another bar, another bar. It will arrange, okay, for every 200 mm. So how many? The question of how many bars I have. Okay, here is I have half. Okay, half of the bar here. Here I have another half. Okay, so the total is 1. Okay, half plus half is equal to 1. And then this is the full bar. Okay, bar number 1, 2, 3, and 4. So plus 4. Okay, plus 4. The total is 5. 5 number of bar. Okay, can you still understand? 5 number of bar. So okay, for 5 number of bar, so it's equal to 5 times 113 equal to 5 times 113. Use your calculator, please. Equal to 565. Okay, mm square. Then you refer to the table. Okay, you refer to the table. Of course, in the exam, you don't have to draw this one. Okay, wasting your time. This is just additional knowledge. Okay, on how to derive the table. Okay, and then you refer to the table by, okay, this is the table. H12 at 200 mm. So here and here 565. Exact. Okay, exact value. So you can calculate. If you don't have the table is limited to 300 only, but you want to try for secondary bar about let's say you want to provide this one OH this one 450. So you want to know the S provided. So the formula is simple, which is equal to, I write down here lah. Okay, 1000 divided by 450 equal to divide by 450, 2.2 something, 2.22. So you multiply by the area of steel bar. If you use H12, so the area is 113. If you use H10, okay, so it will be 78.5. Okay, so times 113, so it's equal to 2.22 times 113. What is the answer? Use your calculator, please.
250.86.
Yes, 250.86, so equal to 251 mm square. So it's similar to this one. Okay, so that's the tips on how to estimate the AS provided with a specific spacing. Okay, so this is the primary bar. Main bar is this one. This is the main bar. Our main bar is here, H12.225. And then this is the secondary bar. Now, the question is how to do the detailing. Okay, the detailing is, okay, for this one, okay, this is actually the last part, okay, but I don't want you to confuse. This is the detailing is usually is last part after we finish checking the deflection and checking the cracking. but it's okay. So for every 1 meter, they will lay down, let's say here, this is your main bar. Main bar usually is at the bottom. So this one is 1 bar here. And there's another 1 bar here. Another 1 bar here. For every 2 to 5 mm. Okay. For every 2 to 5, they will install 1 bar at the bottom. Okay. However, this kind of drawing is very crowded. Okay, it's crowded and you cannot see because the drawing they will never print in color for you. Okay, the color will be black and white, so you will confuse. So in order to simplify the drawing, so you can use the simplified method. So you can use this one. Let's say this is the this is the bar. Okay, you draw the bar by using the computer in AutoCAD. This is 1 bar, means in the X direction. Let's say this is this is let's say X direction is Y. Okay, so this is your bar, and then another part is you use this one arrow. The arrow here up to here. It's along this Y direction. Okay, along the Y direction, and then you might make it here, and then you mark by 0, 1. It's the notes. Okay, 0, 1, and then at the bottom you can write down. Okay, let's say the reinforcement 0, 1 is equal to H12 2 to 5 mm center to center. That's how to do the detailing. Okay, means they will arrange along this arrow, and then for the secondary bar, let me use the other color for secondary bar. Usually for every 550 they will lay down the secondary bar, but if you draw like this one, your drawing will become so crowded. So you simplify, just draw a single bar here. This is your bar, 1 bar, and then let me use the orange color from here. Let's say from here to here, and then you use the arrow, means from end to end. Okay, and this is 0, 2, and then you can write down the notes. 0, 2 is equal to H12 450 mm center to center. Okay, any question? Okay, if no questions for the section 1.1. Okay, for the section 1.1, sorry, I forgot this one. Okay, this is section 1.1. Okay, the diameter. Okay, because the critical part is the load will go to the B1 and B2. So the bottom part must be the main bar. Okay, so the main bar is here at the bottom. Okay, the light blue color, and then you mark as this one. You mark as this one is 0, 1. Okay, so you can refer to the notes, and then for the what color? Plum color. Okay, so for this color, and then for this one, if you using AutoCAD, you have to arrange for offset for every 450 meter. At the top. Okay, so and then you can mark it as 0, 2. Okay, if you cut the section here, let's say you want to do the section 2, 2. Okay, let me do it here. Section 2, 2. Okay, I believe I can. Okay, I better erase this one, and then I make it here. Section 2, 2. Okay. Okay, this is section 2, 2 now. Okay, I cut section here. Section 2, 2 I cut here, let's say. And then to see the reinforcement, okay, where is the location of reinforcement number 1 or the main reinforcement now? At the top or at the bottom? Imagine you cut here. You cut here and then what you see? Kan you cut situ kan? You cut situ. Okay, top or bottom? For the blue color. Okay, it's still at the bottom, but you will see here, like this one. Closer, of course closer, because let's say this is 450. If you are using AutoCAD, it will become easy to draw, okay, because the offset will be easier. So this one is closer because the spacing is 2 to 5. It's still at the bottom, but here is spacing is 2 to 5. And then the secondary bar, this one is secondary bar. So just like this one, okay. This is your secondary bar, you can see here. Okay. So kalau you jaga site nanti, if you are your LI is with the contractor, you jaga site, nanti you boleh perhatikan kat mana dia nak pasang, dekat atas ke kat bawah. Okay. Baru you boleh nampak apa yang you kira. Okay, and next after the okay, actually the detailing is the last part, okay. Okay, next we check because I don't want to jump the shear. Okay, I don't want to explain the shear and then batal balik. Jadi kamu keliru. I don't want you to confuse between where to put the secondary bar and where to put this primary or main bar. Okay, and then step number C, this is step number B, is design and reinforcement. Step number C is we check for shear. Okay, we check for the shear. The VED we got from calculation is 26.44 kilonewton. And then the design shear resistance, okay, which means the capacity of concrete to resist the shear force. If in the beam you directly go to the VRD maximum, kan, for theta equal to 25 degree. If VED is larger than this one, so you check for VRD maximum theta for 45 degree. And if it's in between, you have to find the value of theta. Okay, if VED is still larger than this one, so you have to enlarge your size. Okay, so it's equal to design shear resistance VRD of C is concrete. Okay, capacity of concrete to resist the shear is equal to, in bracket, 0.12 K times the 100 times rho 1 times FCK, okay, times BD. Okay, what is the value of K? K is equal to 1 plus 200 divided by D, okay, square root, and it must be lesser than or equal to 2. Okay, you can refer to the notes of deflection here. Oh, sorry, not deflection. The shear. Okay, you refer the shear reinforcement, note of shear reinforcement. You can see this equation. Okay, that's your task to refer back to the notes. Okay, and then the value of K, let's calculate together. Okay, K equal to 1 plus 200 divided by 139 square root, so equal to
2.2.
okay, 2.2 greater than 2.0, you use K equal to 2.0. So this is the not similar as for deflection, the value of K here. Okay, you don't confuse. Okay, And then row 1 is equal to, based on the AS primary divide BD. So primary is, we provide here 503. Okay, 503. You use the provided as provided for main bar. I mean, the row 1 is for main bar. Okay, so 503 divided by 1000 times 139. So equal to what?
0.0036.
0.0036. Macam ni ya? Macam ni ya? Sebab saya buat tadi based on 200. So dia lain lah. So it's okay, tak apa. So the value of VRDC is equal to, you use this equation. Okay, I just directly write down the equation. 0.12 times K is equal to 2.0 times 100. Okay, this one is, be careful, 100 times 0.0036 times the FCK is equal to 30. So square root of 3. So times the BD times 1000 for B, and D is 139. So what is the value of VRDC? Of course, you have to divide by 1000, okay? To get the unit of kilonewton. Okay, any value?
Seven 3.74.
Sorry?
73.74.
7.7, okay, 774 lah buat. Senang. Okay, kilonewton greater than 26.44. Tadi kan yang kita kira kan, this one. Kilonewton. Okay. Therefore, shear reinforcement is not required. Okay, dalam slab, mana-mana slab, ini je step dia untuk check the shear reinforcement. Very easy, very simple. So you have, you can get satu markah ya. This one is 1 mark, 1 mark, 1, 2, 3 marks, and then this is conclusion, 1 mark. Dah 4 marks here. Okay. Atau sometimes because the K is so simple, so only 0.5 mark here lah. 0.5. This is also 0.5 because this K and row 1 is so simple. Okay. And then you check for D is check deflection. Okay. As usual, this is just like beam. Okay. Just like the step for beam. So rho is equal to AS required, okay, divide by BD. So it's equal to 460 divided by 1000 times 139. So any answer? Zero point?
0.0033.
Okay, good. So rho naught is equal to FCK divided by 1000. So square root of 30 divided by 1000 equal to 0.0005. Okay. So you refer to the table. Okay. K is equal to what? Okay. You refer to this table for deflection. Remember, recall this lesson. For deflection, what is the value of K?
1.0.
Okay, 1.0 because this is a simply supported slab. Okay, either one way or two way, it's simply supported. So K is equal to 1.0. Thank you. So K is equal to 1.0 because it's simply supported. Okay, and then rho naught, rho prime, of course, is equal to 0 because no AS prime. So since the rho is lesser than rho naught, so we can use, okay, refer to these notes again, okay. You can use this equation. You use this equation 7.16a, okay. So L over D basic equal to K times 11 plus 1.5 FCK square times rho naught divided by rho divide 3.2 square root FCK times rho naught divided by rho minus 1. Minus 1, okay, here. Okay. So equal to K is 1.0 divided by 11 plus 1.5 square root of 30 times apa ni? Rho naught is equal to 0.0055 divided by 0.0033 times 3.2 kali dengan square root FCK kali dengan, be careful lah kelas, 0.0055 divided by 0.0033 divided by 1 minus 1 to the power 3. Okay, sama dengan 1.0 11 plus berapa? You better calculate one by one lah. Saya risau kalau you guna calculator takut silap. Okay, here is what the answer here. Okay. What is the answer of here? You better calculate one by one.
13.7.
Okay, 13.7 is for here. 13.7, thank you. Sorry, this one. Okay, 13.7 plus. Any answer? Plus?
9.5.
Okay, good. 9.5. So equal to equal to 30? 30 something kan? 30.
34.2.
4.2.
Okay, good. Thank you. And then, so as usual, it has to be multiplied by the modification factors. First, due to steel, this is simple. AS provided divided by AS required is equal to 503 divided by 560. What is the value? And then second one is due to flange, due to flange. So it's equal to 1.0 because no flange. And then the 3 is due to span, also equal to 1.0 because our span is lesser than 7 meter. Okay, so what is the answer for 1 due to the steel? 1 point?
1.1.
1.1. Okay, good. So the L over D allowable equal to L over D basic multiplied by the modification factors is equal to 34 point berapa tadi? 34.2 times 1.1 times 1.0 times 1.0, so equal to
37.6.
37.6. Okay, so L over D actual is equal to D is 4,000, L 4,000, D is 139, so equal to 28.8 lesser than 37.6, so it's okay. Okay, next, last part, last checking is for cracking. Okay, you can okay, this E, check for cracking. Okay, first our H is equal to 175 mm, lesser than 200 mm. So we can use the rule of detailing from here. Okay, the slab design, you refer to this page if I'm not mistaken. Sorry. Cracking. It's okay. We'll go through the two-way slab by next week. Cracking, the law is here. Okay, this one. Okay, this notes. Okay, notes of slab design. Slide number 25. Checking. This is for okay applicable only for H lesser than or equal to 200 mm. So for the main reinforcement, the maximum spacing shall be 3H or lesser than or equal to 400 mm. Limit is 400 mm. For secondary reinforcement, spacing maximum is 3.5H or lesser than 450 mm. So first you check for main reinforcement. S max is equal to 3H lesser than equal to 400 mm equal to 3 times H is 175 lesser than equal to 400 mm. So equal to berapa? 5?
525.
Okay, 525 mm lesser than equal to 400 mm. So you use S max. Okay, use limit lah. You choose the minimum. You choose minimum between 425 and 400. Okay, so you use S maximum equal to 400 mm. So we provide provided equal to 225 tadi kan, 225 mm lesser than 400 mm, so it's okay. And then you check for secondary reinforcement. S maximum equal to 3H, but okay, this is limited to 450, so equal to 525. Okay, 450. We use S max equal to 450 mm. So yang we also provide equal to 450 mm. So it's still okay. Okay, so that's the difference between checking for main reinforcement and the secondary reinforcement. Okay, any question for the simply supported slab? Before we have a short break, about 10 minutes break. and then we will move to continuous one-way slab. Okay, I believe we can finish the slab design by 2 or 3 lectures only. Okay. Okay, class. So for your exercise, you just repeat this one. Okay, exercise. Let's say exercise for A. Okay, I give you the question here. Exercise for A. Okay. Repeat exercise 4, but change. Okay, you just change the L. You change to 4.3 meter. And then you change the GK, you change the FCK is equal to 25 Newton per millimeter square. You maintain the FYK as 500 Newton per millimeter square. You use GK equal to 1.5. Okay, maintain Newton per millimeter square. But your QK, you can use 3.7, let's say, kilonewton per this is kilonewton, kilonewton per meter square. This is also kilonewton per meter square. And then you can use the, what else? C nominal, try to use 25 mm. And then, ni tabel lah GK ni, QK ni tukar 4.0 lah. 4.0. And then the HF, you maintain as. Sekejap ya. Bagi dengan okay lah, you can maintain as 175 mm. But the diameter of link, you use limit to 10 mm. Okay, you please try solve these equations, solutions. Okay, usually in the final exam, the one question is for the beam. Usually you have to design from main reinforcement, check the deflection, check for shear, and then check the final exam. You have to calculate the you are not given the action, the bending moment and the shear force. You have to calculate. So if you use wrong formula, wrong answer. Okay. In the final exam, based on the past year, I observed that you have to determine the slab safe weight, and then you have to add on with the permanent action in order to got the final GK. So you must know how to determine the slab safe weight of the slab, and then you have to determine the design action and then bending moment and shear force. Okay, you try to solve this question in 45 minutes. Okay, this is to train you during the exam. Okay, now we must upgrade our training system. Okay, other than using the typical answer sheet, you must also try within the specific time. Okay, this is, I hope this method will make you free from nervous later. Okay, you will free from nerves. You can beat your anxiety. Okay. Okay, that's all. Thank you very much for this part.